All right, let's get right into it. There's this massive idea floating around AI, right? That for years, we might have been getting something fundamentally wrong. And I mean, really wrong. It's an idea that has shaped, everything, how we build AI, how we measure it, and it has these huge financial consequences. So today, we're going to flip that on its head and look at things from a totally different angle.
You know the one. It's the question literally everyone is asking. It's that ghost in the machine that stops AI from being something we can truly 100% depend on. We've all been there, right? You ask a model a question and it just confidently makes something up. You get these false, sometimes totally bizarre outputs. So what is going on here? Why does this happen?
Well, the standard answer, the one you hear everywhere, is hallucination. The industry calls it a model defect, a bug. Some weird, unpredictable thing that just pops up in a broken system. The whole assumption is that the model itself is flawed, and our job is to go in and fix it. But what if that entire idea is just wrong? Yeah, think about that for a second. What if this hallucination thing isn't a defect at all? What if it's just a symptom of a totally different problem? And here's the kicker, a problem that's not with the AI, but with us, the people using it. So here it is. This is the big idea. The model is not broken. It's doing exactly what it was built to do. The problem isn't some deep flaw in the AI. It's a failure on our part to give it complete instructions. The model isn't broken. It's underspecified. So let's really break this down. On one side, you have the myth, right? Hallucination is a model defect, some unpredictable glitch we have to hunt down. But the reality, it's so much simpler. It's an input problem. That hallucination is actually a totally predictable side effect of us giving it incomplete instructions. So the solution isn't trying to fix the AI, it's about fixing our input. I mean, just think about it for a sec. When a model gets to a gap in our instructions, like an undefined behavior, what's it going to do? It does the most statistically likely thing it can. It fills the gap. It improvises. That's not a bug. That's the system working perfectly when it doesn't have all the info. For years, we've been blaming the model for our own lack of clarity. It's wild. Okay, so if the problem is that we're underspecifying things, what's the solution? Well, it's a whole new way of thinking, a new paradigm where we stop treating our instructions like these vague, fuzzy prompts and start treating them like complete, actual programs. And when I say a complete specification, what does that actually mean? Look, it's not just about writing a better prompt. No, it's way more than that. It's like a formal contract with the AI that leaves zero room for guessing. We're talking about defining every single input, every processing rule, every possible output, and even what to do when things go wrong. Okay, so take a look at this. This is a real-world example of what I'm talking about. It's a problem definition for a simple chat app. But notice the insane level of detail here. It defines the current state, the state we want to get to, the gap between them, and the impact. When you give an AI this kind of unambiguous, crystal clear detail, there's nothing left for it to make up. And this just changes the entire workflow. All the hard work, the real thinking, it shifts to the very beginning, to creating that perfect, complete specification. Once you've done that, you literally just hand it over to the AI for execution. And the result? You get predictable, reliable, correct output every single time. And this brings us to a really, really crucial way to think about this. This specification is the program. The AI, it's just the compiler. It's the thing that runs the program. When you think about it like that, you realize we don't need a smarter compiler. We just need to write a better program. Right, so once you really accept this new paradigm, the consequences are, well, they're staggering. It forces you to reevaluate the entire, multi-trillion-dollar AI industry. So let's start with benchmarks. Think about it. Every major AI benchmark out there today is basically measuring how good a model is at guessing, at filling in the gaps in our vague prompts. We're literally ranking multi-billion-dollar models based on their ability to improvise. But if the real goal is reliable execution of complete instructions, then we've been measuring a skill that honestly should never even be used in the first place. And this leads to a pretty shocking realization about the money side of things. This whole race to build bigger and bigger models, more and more data centers, it's not actually solving the core problem of reliability. It's just a massive, incredibly expensive workaround. We're building more powerful gap fillers to make up for our bad inputs instead of just, improving the inputs themselves. Now, chew on this for a second. What about all those older, so-called obsolete models? maybe they're not obsolete at all. Maybe they've just been consistently fed these underspecified prompts, and then we blame them for the messy results. Their true capability, we might have never even seen it because our instructions were never good enough to unlock it.
Which brings us to this crucial point. Get this, a smaller, cheaper, last-generation model, if you give it a perfect, complete specification, it will reliably outperform a massive, state-of-the-art model that's just given a sloppy two-sentence prompt. Why? Because the specification is doing the real intellectual heavy lifting that we've been paying these giant models to just kind of approximate. And so, because we've been measuring the wrong thing this whole time and solving the wrong problem, the smallest, most accessible, and most affordable AI models, well, they might just be the most underestimated technology in existence right now. All that power, just sitting there, waiting for us to use it correctly. So, where does this all leave us? What does it all mean? It means the real bottleneck, the actual barrier holding back reliable AI, it was never where we thought it was. The model's capability? Nope, that was never the bottleneck. The training data? Not the bottleneck. The model's size, its parameter count? Never the bottleneck either. The real bottleneck is the human's ability to specify completely. It's us. And you know what? This is the most empowering takeaway of all. The AI isn't some future tech we're all waiting for, hoping it gets perfected. The tool is already here. It's incredibly capable. It's ready. In fact, it's always been ready. It's been waiting for us to catch up. So the next time you sit down to work with an AI, just remember this. The magic isn't in some clever prompt engineering trick, and it's not about finding the biggest, baddest model. The real work, the high-value work that unlocks truly reliable, powerful AI, is the discipline of creating a perfect specification. That's the work. It always was.